Okay, so for 9.9, we're going to study vectors. And so a vector, and you guys have, I think, studied this a little bit in science. And so when we say a vector, we say it's any quantity that has a magnitude, the other name for that is a size. It has a value associated with it, and a direction. And so what really changes things for us mathematically and for physics is that when we start talking about vectors, we start talking about something as having two components, two parts to it that represent it instead of just one part to it. For example, we might be talking about a car, and before we just talked about how fast the car was going, but the speed of the car was not related to the direction the car is going. Now we're saying that a car has both a direction and a speed that it's going, and we're going to always consider those together. And so that's kind of the big thing that's going on with these problems. When we do that, vectors are represented by arrows that has a direction. The arrow points in a certain direction, and then it has a length, and the length is going to be the magnitude, which we'll get to in a second. They're represented by arrows and can be placed on a coordinate grid. Now, one of the important things to notice is when we start talking about the coordinate grid, the actual location of the vector doesn't matter. It's just the length and the direction that matters. So we only pay attention to those, which means it gives us a lot of flexibility for moving vectors around. Okay, so a couple more definitions. The magnitude, which is the size, is also the length of the arrow. This is on a coordinate grid. So when I say the magnitude, what I'm saying is how long is the arrow? What is that line? And so that means we're going to use things like trigonometry and the distance formula to help us out for that. We're also going to have an initial point, and that is the starting point of the vector. One of the things that we're going to do to help us with the math behind vectors is we're going to move it to the point 0, 0. The origin allows us to really be able to do some much easier math. And so what we're going to do is we're going to take a vector, and it's going to be somewhere in the plane, and it doesn't matter where it is, and then we're going to move it to 0, 0 as its initial point. And then we have what's called the terminal point. And a terminal point is the endpoint of a vector. Okay, and that's just going to be the point that's ended. Again, what we're going to do is when we move the initial point to 0, 0, we're going to have to move the terminal point as well to match up to it. Okay, and so for example, we might have a vector that looks like this, where this is the initial point, this is the terminal point, and so we have this arrow that looks like that. Well, what we're going to do is we're going to take that vector and let me see if I can do this by hand. I don't think it's going to let me do it nicely. And we're going to move it, and so that we have the exact same vector, but instead of it being like this, it's going to have the same length and the same direction, but now the initial point is going to be 0, 0, and so then we're going to have to find a new terminal point, which we'll talk about in a second. Okay, and then the way that we represent vectors on the coordinate grid is like this. Whenever you see, so instead of having the parentheses, the curved parentheses like we normally do, if you have these angled brackets like this has a very specific meaning, and this is a vector with initial point 0, 0 and terminal point xy. And so the ending point is at xy, the initial point is at 0, 0. This is going to be really nice for us because it's going to be a way for us to do some really nice and easy math on them. All right, so there's a couple different points of this that we need to be able to do. And so the first thing is we're going to describe them by direction and magnitude. And so that's what we'll do for the rest of this video is talk about direction and magnitude, and then we will talk about go back and talk about coordinates and how to do those. So here's two examples, and then we'll do another video to do the other directions. And so we're going to have a vector with a magnitude of 65 and a direction, and this is something that you're going to have to think through a little bit. That is 50 degrees south. Now notice we're going to use north, south, east, and west, and so you may need to refresh your memory on that a little bit, of east. Okay, so we look at a coordinate grid, and our coordinate grid looks like this. North, south, east, west is going to look like this, and so north is going to be in the positive y direction, east is going to be the positive x direction. We are doing 50 degrees south of east, and so east is this direction, so south of it would be below it, and so our vector is going to look like this. And then our magnitude is going to be 65, and so that means the length of that vector is going to be 65. And what we want to do is we want to find the coordinates associated with this vector. So since I put this at 0, 0 starting, all I need to do is find out what the terminal point is, and then that's going to give me the vector. Well, the nice thing is trig makes this very easy. If you draw in a right triangle that connects the point with the horizontal axis there, the x-axis, then this length is going to be x and this length is going to be y. Note, you need to remember and you need to insert the proper positive and negatives. In this particular example, the y value is going to need to be negative because it's in the fourth quadrant, and in the fourth quadrant, x is positive, y is negative. You should be able to do that without any problem. Okay, so how do I find the x? Well, the cosine of 50 degrees is going to equal x over 65. Right? It's a real simple SOHCAHTOA problem. X is the adjacent side, 65 is the hypotenuse. So the cosine of 50 degrees equals x over 65. So x equals 65 cosine of 50. And then we need to do the y. And so the y, we're going to do the sine of 50 degrees equals y over 65. And so y equals 65 sine of 50. So now we go through and we just type those into our calculator to get our answers. And so we type in, oh, sorry about that. Gotta grab my calculator. We type in 65 cosine of 50, and we get 41 point, we'll round to the nearest hundredth again, 78, and then 65 sine of 50, and we get 49.79. So that means that our coordinate, the answer to this question for this vector is 41.78. Note it's positive, and then negative 49.79. And it's negative because the y value is negative because you're below the x-axis. Okay, another example would be one, and I want you to describe this both in words and coordinates. Spelling coordinates wrong. And so when I take a look at this, this is what we're going to be given. Your vector looks like this. And so you need to be able to think about this as, how do I describe this in words? And then how do I describe it using coordinates? So the first thing is in words. Well, that 25-degree angle, if you think about it, it is north of west, right? This direction is west. We're going above west. And so 25 degrees is north of west. Now, you can have them coming this way. Another way you could describe this is 65 degrees west of north. You don't ever have to do it that way. You can always do it just north of west, north of east, south of west, south of east, but you can do them from the other direction if you want, from time to time. They represent the same vector. And then, so it is going to be a 40 magnitude 40. That is 25 degrees north of west. And then to get the coordinate, you're going to do, remember that this is going to be x comma y. And so your x value is your horizontal value, your y value is your vertical one. And so you're going to say the cosine of 25 equals x over 40. And so x equals 40 cosine 25. And then you're going to say the sine of 25 equals y over 40. So y equals 40 sine 25. Type both of those into your calculator, and you get 40 cosine 25. That gives you 36.25. And then for y, when you do 40 sine 25, you get 16.90. And then for both of those, you have to think about their positive negatives. This is in the second quadrant, so the y value is positive, but the x value is negative. So by coordinates, the answer is negative 36.25, comma 16.90.